Alrighty, this is going to be a demonstration of one of the new features, which is creating a surface model. So I'm going to go through the different options that you can use to create this surface model, how it's done, and what those options will mean for the impact of the performance of the surface model and the output that you'll see. So in this demonstration, I've already gone ahead and entered a standing task that I have, and I've already imported some physical data here and performed a clip of the point so that I have a nice horizontal patch that I suppose you could consider would be a likely candidate of points that would represent a grade. Now, I haven't done the cleanest of jobs in clipping this, but that's kind of intentional because I want to show you what some of the different settings will do with the output of the grade or the surface model. I'll use those two terms interchangeably. Firstly, the tool for creating a surface model is part of the assisted modeling tools. You'll see it here underneath the ones you might be familiar with for creating steel, plane, cylinder, etc. You'll see this assisted surface modeling. Before I open this up, I just want to make a mention that the type of object that's created for the grade is an asset group. So when you're going to be creating the grade, it's not changeable. It's always going to be an asset group, but do make sure that the valid workspace and valid parents is set up so that it's allowed to be created in the particular workspace that you're interested in. In this case, the default is master model, but I could imagine physical data might be a valid workspace for you to create grade or whatever's appropriate for your project. So without further ado, let me open the tool window up here. System modeling tools, and here we are. So there's a few different options that we can configure for creating the grade. I'm going to go through these one at a time with the exception of the first one. I'm going to come back to the model starting point after I've created the grade. Just one quick note is derive from point extents is the default, and it may be acceptable that you leave that as is for most of your grade creation, but I will come back and show you how you can change that for other grade creation. This second setting is the surface model step size. What that is specifying is, well, the grade that's created is actually made up of a lot of small triangles. Well, I say small, but it's dependent upon the size here that you specify. My default unit is millimeters, so I'm able to specify millimeters here. The smaller value I use here, the more fine-tuned, I guess you could say, or the more able to deal with curvatures in the surface, the more detailed it will be, the smaller my triangles will be. There is a caveat, though, because the smaller this value becomes, if I use something like 100 millimeters or 250 millimeters, with larger sets of point clouds over a larger extent, you can see performance start to chug along a little bit. I wouldn't be surprised to see a grade creation with 100 millimeters, for example, take 30, 40, 50 minutes, well, depending on your system, of course. So I'm going to use a value of 250 millimeters, and I just have one scan here, so it shouldn't be too terribly long. The next thing that we specify is the location, which the surface model is going to be created. Remember, I've already shown you that asset group is going to be the type that it's created, so I must specify a valid parent. In this case, subdiscipline, I've already created one in my hierarchy, is a valid parent. So there we are. The next setting is to fill holes in the surface model. What this means is my physical data might be lacking points in certain areas, but I'd kind of like the algorithm to fill in those holes as best as it can as it's processing this physical data. So if this is checked, when I have places like, well, where the tripod was or missing areas of points here, I'll let the algorithm sort of interpolate the difference and fill in as best as it can. Feel free to play with filling holes on or off and see if you like the results one way or the other. The next setting is whether I want a quick data pass to be done, the physical data, or a more precise but more time-consuming pass to be done. So with this checked, it'll be a fairly quick sweep of the point clouds. It'll use not every single point because I mean we could obviously be talking about millions and millions of points. It'll use a more cursory approach to determining how the grade ought to look, which I will say in my tests, but feel free to give me your feedback. In my tests, a cursory pass of the physical data was good enough, and it wasn't exactly worth the price of going through every single point. But it's up to your discretion. I would expect to see, depending on your data set, that the quick pass versus a non-quick pass for large numbers of points, if you're displaying tons of regions, could make a significant difference in the performance. My headset's just beeping at me. Excuse me. Let me plug this guy in. The joys and pitfalls of wireless technology. Alrighty, and the very last setting here is quite an important one, as it has a significant impact on the performance that it's going to take, and that's whether I want a mutable grade to be created. What this means is all those little triangles that the grade is being comprised of, do I want every single little triangle to be an object in and of itself that I can delete? Right? If you check this on, a mutable grade, it will create every single little bit of the grade or surface model as a triangle that I can delete. So for example, if I have, well, part of my physical data that I haven't clipped, maybe I want to remove that grade, I will only be able to do that, parts of that grade, if I create a mutable surface model. This is a significant performance hit if I turn this on. Expect, roughly speaking, about a 25 to 50% additional time to create the grade if I check this on. So without further ado, let me go ahead and create this. I think all my settings are in order. I'll go ahead and create the grade. This should take, just to commit the transaction to the database, hopefully not more than a minute or so. And just for sanity check, so I don't have to record, I'm going to stop the video here, and you can pick up the second part as I explain a few other bits and pieces of the surface model and show you the demonstration of what's been completed. Please pick up after part 2. Thank you.